Welcome back to Learning with Merit. Today we are going to take a look at JavaScript and how we can integrate JavaScript into our HTML files and web pages. What is JavaScript? And then we're going to do a basic little overview of JavaScript and programming concepts in general when it comes to procedural programming languages. Here we have JavaScript. What is it? We're going to look at external JavaScript, where we add a script.js file. Internal JavaScript, where we use the scripting tags. Inline JavaScript, where we use an attribute that allows us to add a function to a particular element. And then we're going to do a quick overview of JavaScript, where we talk about data types, variables, operators, conditionals, loops, functions, classes, and objects. These things, of course, being very important in programming. So let's first take a look at JavaScript and what is it. So JavaScript is a high-level language, meaning it's fairly easy for humans to read, but not as easy for the computer to understand. And so it is also an interpreted programming language, meaning that we need some tool, an interpreter, to read this high-level text stuff that we write and convert it into something that the computer can understand. It's designed to make web pages interactive and dynamic, and this is what does all the fancy stuff, clicking on buttons and doing functions and doing all these interesting things like video games and stuff that you may play on a website, or these real dynamic animations or things like that. It makes the web page interactive and dynamic. So all the cool stuff. It is used for what we call client-side scripting. Now, what this means is JavaScript is a programming language we typically associate with being on the client side. In this case, what's the client? The client is your browser. And what it does is it runs on the client side to create dynamic things, deal with events like clicking on stuff, and to interact with the user. Again, it's all about making the web page interactive, and that's what JavaScript is good for. There are three ways that we can add JavaScript to an HTML file. One of them is external JavaScript. So we use a file like script.js, like this one right here, and we attach it to an HTML file. Or we could use internal JavaScript, meaning we could use two script tags, and inside those script tags we could write some JavaScript there that would be directly inside the HTML document. Or we can do inline JavaScript, where we actually tend to combine that with either internal or external JavaScript. And the reason that we do that is because inline JavaScript is where we might be handling an event of some kind. So we might use event attributes to handle different events like clicking on a particular element, and then we get the computer to do something based on that. So that's JavaScript in a nutshell, basically what it is and what we're going to do with it. So there are three ways that we can add JavaScript to an HTML file. Here you see my files I have right here. I have index.html, script.js, and styles.css. Here I have the index.html file open, and we can scroll through that and see that there's really not that much going on. But if I want to add some JavaScript, whatever's in this JavaScript file right here, to the actual index.html file, right, there's a special way that I need to do that. And we call this right here, we call this external JavaScript. So external JavaScript is code that is stored in a separate or external file, in this case script.js, and it's linked to our HTML document. Now, we're going to use the script tag with the source attribute to actually add this external JavaScript. So here we have script, then I'm going to add source equals, then script.js, the name of the file. You notice that that file is in the same folder as index.html, so we're good there. And then I'm just going to close that script tag right there. It's as simple as that. I open a script tag, I add the source attribute with the name of the file I want to link, and I close the script tag, and we have successfully added our external JavaScript, whatever we want in this file here, to actually run. Next, we're going to look at some internal JavaScript. So I have removed my external JavaScript, and now I want to add some internal JavaScript to my HTML file. Well, what I'm going to do here is I'm going to use some style tags. So if we take a look at this, we've got internal JavaScript. And you notice I've stuck it up here in between the head tags, so as a part of the head element. So internal JavaScript is code that's directly written within the script tags, and I can stick it right here in this HTML document. I don't have to put it in a separate file if I don't want to. Now, it's usually a better idea to stick it in a separate file, but we don't have to if we don't want to. And we're going to use these script tags to write code between those tags. So here I've created 2 script tags. And now I'm going to write what is called a JavaScript function. And I'm defining what this function does. So we say function, I give it a name. This function is called showMessage. And then I write curly braces. Inside the curly braces, I'm going to use an object called console. I'm going to use dot syntax by adding a dot. I'm going to call a method called log. This is a function that I can use with the object console to display something, and I'll show you actually where to see that displayed at. And then I'm going to have it display, we use console.log to show output in JavaScript. So whenever this script runs, so this HTML page will load, this script will run, right? Assuming that I actually call this method, or I'm sorry, this function here. And it will show us some output in JavaScript. So what I'm going to do is I'm going to hit enter here. I'm going to type show message, parentheses. This is what we call a function call. So this is defining what show message is supposed to do. This is the act of asking the computer to do it right here. So we call this the definition up here, and this the call down here. So I'm going to save this file. And what I'm going to do is I'm going to right click on here and I'm going to copy the path. I'm going to open up my favorite browser here. And I'm going to paste that path and go to it. Now you won't see anything on the screen other than the 2 buttons that are defined in the code. So if we come down here, I've defined 2 buttons called click me and click me 1 and 2 down here in a span. And we're going to use that for some inline JavaScript later. But right now we don't see any of this doing anything here. And that is because we actually have to look at the console of our developer tools. So I'm going to go up here to the right hand corner, and this should be very similar in whatever you're doing. You could also use F12, but you're going to go to more tools and you're going to find developer tools and open those up. And I'm going to switch this just to make it a little easier for us to look at. I'm going to switch it using the dock tool here to dock it to the bottom. And here you'll see the HTML that is actually building this web page, and you can see me hover over different things. I can click inside the span and see those 2 buttons, right? And then if I go up here inside of the head tag, I can actually see, right, where we have the script tags and the JavaScript that I wrote. But again, we still don't see where it says this. We use console.log to show output in JavaScript. That's because we want to look at the console. So up here at the top, I'm going to find console and click on that. And if you look right here, this is where it output. So I'll actually show you where it outputs that again. If I reload the page, every time I reload the page, it does it again. We use console.log to show output in JavaScript. So this is where I can actually see the output of what I did. If I want to change that, so we go back to our HTML page here, I can change that console.log to say whatever I want. I could say, whoops, I could say, I've got caps lock on. I could say, hello world, like this. And if I do that and I save my index.html page and I go back here and I reload, you'll see that it now says hello world in the console. And that's why it's called console.log, is because it logs information to the console where we can see it. So that's how we add some internal JavaScript to our file, right here in between the script tags. Now we're going to talk about inline JavaScript, which is a little different than maybe inline CSS, for example. And the reason is with inline CSS, we can sort of directly write the CSS inside of a style attribute. But in this case, we sort of need our JavaScript to be somewhere else to refer to as well when we write inline JavaScript. So here's what I've done. I've created some internal JavaScript, two functions, one called doStuff, which is going to log to the console stuff is being done, and another function called otherStuff, which is going to log to the console other stuff is being done. And this is inside of our script tags. We know this to be internal JavaScript. To write inline JavaScript, we're going to do that down here, and the way we use inline JavaScript is usually so that when some event occurs, we can run some function based on that event. So let's take a look at that. So first, inline JavaScript. This is code we're directly adding to HTML elements using something like the onClick attribute or other event attributes. And we're going to take a look at some other event attributes that we have here. So there are a bunch of them. These are just a few. So we have onClick, and we have on mouse over, mouse out, on change, on submit, key down, key up, focus, blur, load, unload, resize, scroll, all different ones here that we can use to trigger JavaScript functions. So now if we come down here and we look at our two elements, we have two button elements, and what we're going to do is we're going to add some inline JavaScript to these button elements. So we're using an event attribute. That's going to be one of these things up here. These are all event attributes. And the one I'm going to use is onClick because it's the simplest one. And that's what we do with buttons. We click them. So we're going to use the onClick attribute, onClick equals. And then in quotes, we're going to write the name of the function call. So if we look up here at doStuff, this is the definition for doStuff. And we are writing the function call down here, doStuff in parentheses. I'm going to do the same thing for button 2, but on button 2, I'm going to call otherStuff. So now what we have is when I click on button 1, the doStuff function should run. So what it should do is it should log to the console stuff is being done. And then if I click button 2, it should say otherStuff, whatever the otherStuff function does. So in this case, it's going to say other stuff is being done in the console. So we're going to save this file. I'm going to come up here and I'm going to copy its path, and I'm going to go to my favorite browser and make sure that we have the correct path. Looks like we do. And I'm going to reload. Now here I'm looking at the console, and you'll notice there is nothing in the console right now. But if I click button 1, you see stuff is being done is logged to the console. If I click it again, you'll see it says it twice. And then 3 times, 4 times, 5 times, right? I'm going to keep clicking it. It's going to say stuff is being done, and it says it 6 times. If I click on button 2, now it says other stuff is being done. And I can click on that a bunch of times. It says other stuff is being done. So every time I click, see, now it's going to say stuff is being done again. And I can alternate back and forth, and you'll see that they keep popping up. And every time I repeat it, it's just going to add a number in the console. And this is just doing something simple for us so that we can see that it's repeated for 3 lines. So we repeated other stuff is being done 8 times up here, 3 times for stuff is being done, and then I alternated through here. So it allowed me to do some function by clicking on a button. And that's what that inline CSS is very useful for, is to allow us to, or I'm sorry, inline JavaScript, I should say, is very useful for allowing us to perform some function when we do something like click on a button or scroll or do something like that. So remember, when we add inline JavaScript, what we're usually doing is we are going to use some event attribute like onClick, and then we are going to ask it to call some function by using the function call and then in parentheses around that, in quotation marks, I should say, in quotation marks around that. Because again, we are writing inside of an attribute. So that is inline JavaScript. Now we're going to do a little overview of JavaScript. Now it's important to understand that this is not just an overview of JavaScript itself, but an overview of programming languages that are like JavaScript in the sense that they are procedural and object-oriented. So this means that many of the concepts that we apply here will be the same as we apply them in things like Python or Java or C or any of those different types of languages. So let's take a little overview. Of course, we're not looking for a lot of detail here, but we want to understand basic programming in JavaScript. Now, the first thing we're going to do is we need to talk about a key programming concept, which is that code is read and executed from top to bottom and left to right. So we read code and execute code much like you would in a book, right? If you're reading a book. We tend to read top to bottom and left to right, and that's how we would read a book and how we would read files and things like that. So the computer does the same thing. And because JavaScript is an interpreted language, that's exactly how it's executed as well. It goes line by line, and it reads and then executes line by line, and that's how the interpreter works. Now, in other languages, that's not necessarily true because there are compiled languages, but the basic sentiment holds true. Now, we need to look at comments. It's the first thing you should learn in every language is how to make a comment so that you can make notes about your code as you're learning a language. So, a single line comment in JavaScript uses the double forward slash like that. This is a single line comment. If I want to make a multi-line comment, I use a forward slash and an asterisk. And then when I need to close it, I use an asterisk and then a forward slash, and that allows me to make a multi-line comment. You see here, it's all grayed out. Next, we need to talk about data types. Now, data types are extremely important in programming, and the reason is because we need a way to represent different types of information or different data to the computer. And we're going to go over the most common data types that may appear in some way, shape, or form in every programming language. Now, I'm going to show you literals first. Now, remember, if you don't know what literal means, it means the actual value. What I'm about to show you doesn't represent anything else. It is what I am showing you. It is that value. It's not a variable or anything else that is representing something else. It is that value. So let's take a look at these literal types. We have Booleans. Booleans are true or false values, right? And in JavaScript, we use lowercase t, true, and lowercase f, false. These are our Boolean values. There are only two of them, true or false. We also might have integers. Now in JavaScript, we just call these number types. They sort of lump all number types together. But what we have is an integer 2, which is a whole number, meaning it doesn't have a fractional part. If we use 2.0, this is a float for floating point. And the reason why we call it a float for floating point is because that little dot right there is a floating point. That's what we call it, that thing right there. So that's a float value. 3.14 would also be another float value. Then we have characters. Now, characters in JavaScript are just treated as single character strings, right? In this case, I only have the letter A there, but I have told the computer this is meant to be the character A. Right? If I put several characters together, like in the word hello, I get a string or a group of characters together. And this is how I represent all text in programming, is in quotes, so the computer understands this is meant to be text information as opposed to a number. For example, if I put 2 in quotes, it would also be a string. In this case, it would actually be a character because I only put 2 in quotes. We have arrays or lists. And there are a lot of different what we call collections types or groups of things that we might use. And we're going to call this an array for right now, but you can think of it as a list of objects. So in this case, I have a string, or I have the character A, character B, character C, and character D. And this is a group or an array or a list, however you want to see it. And technically, these are also objects in JavaScript. We'll talk about those in just a second. Now, we might also have something that you think or we should think of as a dictionary or a hash map. And in JavaScript, these are just treated as objects as well. And so what they have is they have key value pairs. So we have A in quotes, and its value is 97. We might have B in quotes, and its value is 98. Or C in quotes, and its value is 99. And then the last data type that we need to know about is sort of what we call a custom data type. So we can define how this data is supposed to work, and we call that an object. So in this case, console okay, is a variable that stores a particular object. And what does it store? Actually, hover over it, you can see this is my little tool here. It stores a console data type, right? In this case, it's an object, right? And console as a data type doesn't make much sense to us. What is a console? It's a custom data type, and we typically call those classes. So these are our basic data types. We have booleans, which are true or false values, integers, which are like the whole number 2. We have floats, which include the floating point, or the what we think of as a decimal point. We have the character A, or characters, so we have multiple characters that we could use. If we string some characters together, we get a data type called a string. If we group some values together inside of square brackets, this is called an array or a list. If we create something inside of curly braces here and we have a key with a value, we call that a dictionary or a hash map. And in JavaScript, these are just objects that we can create this way. So we also have custom data types, which are objects. So those are data types in JavaScript. In programming, variables are containers that we use for storing data values. So we've already talked about data types like our booleans, integers, floats, characters, strings, arrays, dictionaries, and objects. We have these different data types, but we need a way to store them and use them, and even, have the value sometimes change that we're dealing with. And of course, that's why we use variables. So in JavaScript, we declare our variables using keywords like var, let, or const. And var is pretty simple. It stands for variable. And let's go ahead and create one like that. So we have var, my variable. I'm going to use the equal sign. And then provided a value, here is the literal value I'm giving it. This is a string literal. My value varies. So my variable stores a string, and if I hover over it, you can even see that. So var, my variable, stores a string. Now we might also use the let keyword. So let message, that's my new variable name, equal goodbye world. So if I hover over there, you'll see that let message also stores a string literal. So here we have goodbye world as our string literal, message is the variable name, and we have let in front of that to declare that. Here's another one, let x equal 6. So this time, x is going to store a number. And we can see that it's a number type in JavaScript because they lump the integers and floats together into a number type. So now we have let y equal 8. That's another variable we might have. And again, you'll see it's let y and it stores a number. And so we have x and y that are storing different values, and maybe later I want to change the value of x and y, but still use them in my program, and that's what variables are good for. Maybe I want to change the message later in my program. Well, again, that's what variables are good for. I can change the value that a variable stores, and that's useful to me in my program because sometimes things need to change because something has happened, right? And then in general, it is better to use let. So if you're, var is sort of old. In JavaScript, mostly we use let now if we need the value to be able to change. Now there's also the last one, const, and this stands for constant. And this is for a value that we don't expect to change. For example, like pi. Here I've made pi equal to 3.14, and pi is not going to ever be a different value, right? We wouldn't expect pi to be different. And so it's a constant, and we're going to leave it as a constant. So here we've created 5 different variables. And of course, by the way, we can also see it's const pi, and we can just go ahead and see the value of 3.14 there. So I've created 5 different variables here, and they store some different data types, including a float number type, 2 integer number types, and a couple of string types as we have stored them here. So that's variables. Basically, they're just storage containers for values that we might use later. Now let's talk about operators. So now that we know about our data types that we have, and we know how to store these data types in a location to use them later, now we need to know how to do operations. and we need operators for that. And you already know about operators. If you've ever had a math class before, you already know about a great many operators. There's only a few that we use in programming that you've probably never seen. So these are symbols or keywords that perform operations on variables and their values. So let's take a look here. So first we have what we call an assignment operator. So their first assignment operator is equals. There are others, what we call compound assignment operators, but we're not going to look at them here. But basically, we just have an equal sign. And a single equal sign is something that we use for assignment. So what we're saying is the variable a will have the value 10. So it stores the value 10. We're doing the same thing here with b. We're saying b is equal to the value 2. It's going to store the value 2. Now, we can talk about some other operators, arithmetic. Now, before you got into an algebra class, you mostly did arithmetic, right? And arithmetic operators are what we use for arithmetic. So these are going to be all operators you should probably already know. For example, the plus sign. We use that for addition. So if I do a plus b, that should get me 12. Then I have a minus b for subtraction. That should give me 8. A times b, we're going to use an asterisk for multiplication. That should give me 20. A divided by b, we're going to use a forward slash for division. That should give me the number 5. A percent b, now this percent symbol is what we call remainder or modulo in programming. And you did this back probably way in grade school. But think back to when you used to have remainders when you did division. That's what this is right here. So it just so happens that 10 divided by 2 has a remainder of 0. So a modulo b or a remainder b would be 0, even though the answer to the division was 5. Now we have plus plus, which is increment, which means to add 1 to a. So if I did a plus plus, I would get 11. If I did a minus minus, this is the decrement operation, or to subtract 1, I would get 9. That covers our basic arithmetic operators. Now we have relational operators, most of which are what you think of as inequalities from maybe a math class you've had. So first we're going to have our comparison equal sign. So there is a difference between assignment equals and comparison equals, and here we can see how we denote that. So we have equals equals to see if two things are equal to each other. In this case, a and b are not equal to each other, so we know that that is false. So all of these relational operators will be either true or false when we look at them. They're not going to bring back a number, for example. This is how we say not equal to. So we're checking, is a not equal to b? Well, a is 10 and b is 2, so we know that's true. They're not equal. Here we have greater than, so a greater than b. Well, 10 is greater than 2, so that's true. A greater than or equal to b, again true. A less than b, we know that that is false. A less than or equal to b, we know that that is also false. And notice this is how, since we can't use the little underline like we would when we were writing it maybe in a math class, we use the less than sign and then the equal sign right next to each other, or the greater than sign and then the equal sign right next to each other. And these are our relational operators. Why? Because they describe a relationship. Now we've got some logical operators. These are the ones you may have never seen before, and there are only 3 of them we really need to know. One is called not, right? It's also known as negation. Now what this does is not is going to result in the opposite. So C is equal to the value of true. If I say not true, well, you should understand what that means. If I said that to you as a sentence, something's not true, that must mean that it's false, right? If I do not D here, since D is false, if it's not false, well then it must be true. There are only 2 options there. Now we have the AND operator. This is, are the 2 things both true? So if both things are true, we get true. If either one of them is false, or both of them are false, we get false. So you can think of this as like am I holding something in my left hand and in my right hand? Only when I'm holding things in both hands is that true, right? So C and D, we use two ampersands for and this is going to be false. Why? Because C is true, but D is false. Then we have the or operator. You can think of it again if we use the holding something in your hands example. Am I holding something in my left hand or my right hand? As long as there is at least one thing in one of my hands, it would be true. So since C is true, you could say that's my left hand. I'm holding something in my left hand, but I'm not holding something in my right hand. It's still true because I said or. Is it this or that? Well, that's true. So we have not, and or as our logical operators. So if we put all that together, we have four types of operators. We have assignment operators, arithmetic operators, relational, and logical operators. Control flow statements are how we actually literally control the flow of the code, right? So sometimes we want the computer to make a decision. Now that we know how to perform some operations on that data that we store in variables, right? Now sometimes maybe I want it to make a decision to do this thing as opposed to doing this other thing, right? I need a way to make some sort of decision or control the flow of my program. So the two that we really deal with are conditionals and loops, and we're going to start with a conditional. So here I have conditionals. These are structures that allow us to make decisions in our code. And the way we identify these conditional statements is this right here: if, else if, and else. If you see if, else if, and else, you're looking at a conditional statement. So here, we're going to create two variables. X is going to be equal to 1, and y is going to be equal to 10. Now I'm going to add the if keyword here, and then next to it, I'm going to provide a condition. So we're going to say if x is equal to y. Well, if x is equal to y, then what I want to do is I want message to be equal to x and y are equal. Else if, so now we're going to check, basically, if this first thing is not true, if x is not equal to y, then we're going to check something else. So we're going to say if x is greater than y, we want message to say x is larger than y. And finally, if both of those things are not true, so x is not equal to y and x is not greater than y, then what we're going to do is, if we made it this far, we're just going to run whatever the last thing is. So now we're going to say message is equal to y is larger than x. And of course, we know that's true because if I've checked if they're equal and if I've checked if x is greater, the only thing it could be at the end is that y is greater. So the way this works is if the condition here is not true, then we skip this. If this condition is then not true, then we skip this. And then finally, we just run this if both of these things above it were false. Let's say that we changed it so that x was now greater than y. So I changed x to 11. Now what would happen is it would say, is x equal to y? 11 and 10 are not equal, so we skip this if. Then we check this if right here, and it says, yep, x is greater than y, so we're going to make message x is larger than y. And then finally, if I made them equal, what would happen is it would check this first if, it would see that x is in fact equal to y, and the message would be set to x and y are equal. So what you'll see is inside of each of these little blocks where I've indented here, that is the code that I want to run if a particular condition occurs. And this is why we call them conditionals, because the conditionals allow us to make decisions. If this thing is true, run this code. If it's not, check this. If that's true, run this code. If it's not, I want you to run this thing down here at the bottom. Okay? So these are conditionals, and that's basically it for them. I mean, there's a lot of different ways you can use conditionals, but they're fairly simple to identify. Loops are also a form of control flow statement. So now that we know how to make decisions in code, if this thing occurs, do this. Now maybe we need to do something repetitively, and we might have a condition for that as well. as to when to stop doing something repetitively. But that's what loops are for, is doing a repetitive thing over and over and over. And there are two types of those loops. So these are used for repetitive execution of a particular block of code that we want to do multiple times, and without having to copy and paste the code over and over and over the number of times we want to do it. And then there are common loop types, the while and the for loop, and you're going to see these in pretty much every language. If we take a look here, while loops are going to repeat a block of code as long as we have some condition that is true. So if we write a while loop here I'm going to create a variable called count. And we're going to do a very simple little while loop. We're going to use the while keyword, and then in parentheses next to it, we're going to put the condition. And then inside these curly braces, we're going to put the block of code that it is going to do repetitively. So the condition is while count is less than or equal to 10. Well, it is currently less than or equal to 10. So that is true. So now what we're going to do is whatever we put inside this code block. So we're going to console.log, or show on the screen, right, whatever the count currently is. And then we're going to increase the count by 1. This is our increment operator. So if we take a look at this before we go on to for loops here, if we take a look at this, what we're basically going to do is repetitively print out the count on the screen. So first count will be 1. We'll print out 1, it'll increase. Then we'll come back around, count will be now 2. Then we'll print 2. Then count will increase. Then it'll be 3. Then we'll print 3. All the way up to the point where we finally get to where count is now 11. And so when count is no longer less than or equal to 10, we stop the while loop and move on in our code. And that's how the while loop works. It uses this condition right here to determine when to stop repeating. Now, for loops we use for iterating or looping over a range of values or elements. So for loops are a little different than while loops, but they basically do the same thing. They're going to do something repetitively. So here we have for. We're going to use the keyword for. Then we're going to create a variable inside of the parentheses here. We're going to call it I, and we're going to set it to 0. Then we're going to say while I is less than 5. And at the end, we want to increase I. So basically, we're creating a range of values here. We're saying while I is 0, 1, 2, 3, or 4, we want to continue doing this for loop, basically. And we're going to increase every time. So the first loop, I is going to be 0, and we're going to continue until I is finally 5, and then we will stop the for loop. And what we're going to do inside this for loop is console.log. And we're going to say looping plus I. And the reason I'm going to do that is the I indicates what loop we're on. So the way this one will work is we will start I at 0. It will say looping plus 0. So it'll be looping 0. Then we will increase I. I will now be 1. It'll be looping 1. Then I will be 2. Looping 2. I will be 3. Looping 3. I will be 4. Looping 4. And then finally, once I becomes 5, we will stop because I is no longer less than 5. And we will break out of this for loop and continue on to the next piece of code. So we have two different ways of doing something repetitively. We have while loops and we have for loops. So functions are reusable blocks of code that we can use to perform a specific task. So now that we have data and we have variables that can store the data, and we have operators to do stuff with the data, and we have conditionals that allow us to make decisions, and we have loops that allow us to do things repetitively, now we need a way to sort of group that stuff together to perform a specific task, right? And that specific task we call a function. Right? So we might write something to count for us, or we might write something to display something on the screen, or any number of things. So these little reusable code blocks make our lives a lot easier, especially once you start to write lots and lots of code. So first we must define a function, and then we must ask the computer to do it. It's a lot like when you were learning, very, very young, I'm sure, how to count, right? How did you learn how to count? Well, one way or another, somebody taught it to you. But think, even though you know how to count, you're not necessarily counting right now. It's the same thing with the computer. We must first teach it how to do something before we ask it to do it. And teaching it doesn't mean it's going to do it. It just means that it understands how if you were to ask it to do it. So let's look at an example of this. So our function definition, we are going to create a function by specifying its name, what we call parameters, meaning values we need to give to it, right? Because maybe if I asked you to count, I would need to give you some number to count to, right? Otherwise, you may just count forever, right? And then the code to be executed inside of the block. So here's how we do that. In JavaScript, we're going to say function to indicate we are defining a function. We're going to give it a name, in this case, hello. We're going to put parentheses next to it. In this case, we have no parameters for hello. So that we have nothing inside those parentheses. And then inside these curly braces, we're going to provide the code block to be executed when we ask the computer to hello. So I'm going to ask it to console.log, and it's going to log the hello function was called. So right now, I've defined what hello is. If I call hello, it's going to do console.log, and on that screen, it's going to say the hello function was called. But right now, it hasn't done it. I've just taught the computer how. Now, the function call is very important because this is asking the computer to do it. So we're instructing a function to execute when we are doing a function call. Here, all we have done is defined what it does, but we haven't asked the computer to do it. So we're going to use the function's name followed by parentheses, and then any arguments, which means if we had parameters up here, we would provide values. So it's like me saying, for example, if I asked you to count, you might need a number to count to. The number would be the parameter or something you need, right, in order to know what to count to. And the number I give you, like 10, for example, would be the argument. So I might say count to 10, and I have called the function count and given you the value 10 or the argument 10 to do it with. So here we have the hello function name. I'm going to ask the computer to hello and put parentheses next to it. And now what I've done is I have called the function. So by saying hello and then parentheses, I have asked the computer to perform this function that we defined up here. And what it will do at this point in the code is console.log the hello function was called. Right? And that is what we are doing there with functions. So imagine if I had a whole bunch of all of this stuff up here, a bunch of different operations and conditionals and while loops and for loops, wouldn't it be very simple to write all of that here inside of this function definition and then just say, hey, do that thing, right? It makes it a lot simpler, especially as programming gets more and more complex. Next, we're going to look at classes. Now, classes are one of the more complicated things for beginners to understand. And the reason is because a class is what we call a blueprint for creating objects. So you can think of it like this. At some point, I get to the point in programming where functions are really helpful, but now I sort of need to group functions and the data, so like this data up here, if I come up here to like my variables that are storing values, I need a way to sort of group that together to perform a particular task, right? So it's like we might have something, right? For example, like an animal. Let's use an animal as our example here. So we're going to define an animal class or a blueprint for creating animals, right? There are a lot of animals out there, but we know that animals have things that they are, and we also have things that they do. And that's what we are typically defining inside of a class here. So we're going to take a look at that. Here is what we call a method. So it looks like a function. I haven't said function, but it's very similar to a function. This is a special method we call a constructor. The constructor is there to build an object, right? So we have a blueprint. We need to be able to build something with that blueprint. That's what the constructor is for. And then we have what we call parameters. The two parameters here are name and species. So when I create a new animal, I need to give it a name, and I need to say what species it is. And then we store that as the name of the animal and the species of the animal that we've created, right? And I can use this to make many, 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 many animals, right? And every animal may have a different name and a different species, but we know all animals will have a name and a species. And that's what this constructor is for right here. We might have some other little functions in here. For example, we may have a method to display information about an animal. So what this does is it is going to log to the console, it's going to say name, and then it's going to retrieve the name of the animal and stick it right there. It may also say species, and then it's going to retrieve the name of whatever the species is and say it right there. Then maybe I need a way to have the animal make a sound. So we've got some generic animal sound here. So we're just going to assume that all animals make the same sound, and that's what our sound method is going to do. And the reason this is using the get word here is we call this a getter. You don't have to know that just yet, but basically it's getting something. It's retrieving a value. In this case, it's retrieving the sound that an animal makes. And then down here at the bottom we have this one. This is called a set. This is a setter. It's for changing a value, but it's also just another method, just another little function that's doing something. It has the parameter new species. So all this little update species function or method is doing is it's taking in the new species name and changing the old one to be the new name. And that's all it is. So here's what we've done. We've defined a class called animal. We build animals using this method called the constructor. And when we build an animal, we give it a name and we give it a species. Once I've built an animal, I can ask it to display info, and it will tell me its name and its species. Once I've built an animal, I could also ask it to make a sound, and it would literally just return some generic animal sound. Or I could ask it to update its species, and we would give it a new species to call it, and it would change the species value. So we've created an effective blueprint for our animals. Right? We can build animals with our constructor here, and we can do these things with our animal class. So next, we're going to look at actually making an animal object and seeing what we can do with it. Now we're going to look at objects. So we're going to make an object of this animal class, right? So I created the blueprint for making an animal. Now I'm going to actually make an animal. And we can make as many different animals as we want, but we're just going to make something simple here. So objects are what we call an instance of a class, right? And it's going to store two things, data. In this case, the data that we're storing is name and species. And then it's going to store methods that operate on that data. So if we look at this, display info operates on name and species. Sound just so happens to not operate on either of these pieces of data, but that's okay. We can have methods that do stuff like this too. And then also we have this method down here that is operating on the species, right? So we have two things. We have data and we have methods that operate on that data. So these objects are, again, important that we understand they're instances of a class, or we build them from the class blueprint. And then in JavaScript, we could also think of them as a collection of key value pairs. Now, this has a lot to do with dictionaries, for example, in the way that they are actually used. Anyway, moving on with how we deal with objects. So to construct an object or build an object in JavaScript from this animal class, what we're going to do is we're going to use that special method. That special method is this one right here called the constructor. And what we're going to do is we're going to create the new object by giving a variable that will store the object and then saying new and calling the constructor method. So we're going to say const tiger, because we're going to make a tiger, is equal to new. And then we're going to use the animal constructor, but I need to give animal two things, right? Here's my constructor. I need to give it a name and a species for my tiger. So we're going to call our tiger Tony, and the species we're just going to call tiger. So now I have successfully created a new animal. This right here is creating the actual object in memory, and this is storing a reference to that object, meaning you can think of it as it's a little container for the object. So this creates a new instance of the animal class or an object. We always are going to use variable equals new constructor, and our tiger variable stores the animal object, and of course new animal Tony Tiger creates the new animal object with two properties, Tony and Tiger, where Tony is the name and Tiger is the species. Now what can we do with this object that we've created? Well, we can access the properties of it and look at those properties now that we've grouped it with some other things. The act of looking up the value. And then we use something called dot syntax. So we're going to use object, dot, and then the variable or the property that we're looking for. So here we've got Tiger dot name. And this, of course, is Tony. And here Tiger refers to the object that we have in memory, and we are accessing the name property of that object. Then console.log, we're going to use this to output something, right? If I did console.log tiger.name, we'd actually be able to see the value in the console log. Now, this is going to output Tony. But remember, you may notice that this says console and then dot. If you've paid attention to what we've done here, you can see that console must be an object of some sort. And in fact, it is an object of the console class. Right? So console is itself an object. And what that means is it's not an animal object, but it is also an object in JavaScript. And .log is what we call a method. Speaking of methods, let's actually talk about methods. Calling methods in JavaScript is we are asking the computer to perform a function that we defined inside of the class. So if we scroll up here to the class, we have three things other than the constructor. The constructor also counts as a method, but we have three things other than the constructor that we defined for animals to be able to do. They can display their info, they can sound, or they can update species. That's what animals can do. So if we come down here and we ask it to actually do one of those things, we're going to use tiger and then dot. So we've got object dot method, and then we need parentheses, of course. So we're going to do tiger dot display info parentheses. And this is going to output name, Tony, species, tiger. And what it does is it goes and gets the tiger's name, Tony, and the tiger species, which just so happens to be tiger. And that is what is going to output using that display info method. Remember that tiger refers to the object and display info is the method being called on that object. And then we have tiger dot, because we're going to do another one. We're going to do tiger dot sound. Well, the output for that is just some generic animal sound because we didn't tell it to do anything special there. Last, we might do tiger dot update species. And then we're going to pass in an argument here. So we're going to say tiger dot update species. Remember, update species, this right here expects us to give it a new species. So here's our parameter, new species. And the argument that we are going to give it is the actual scientific name for a Bengal tiger. All right, this is the genus, and this is the specific epithet for a Bengal tiger. And so instead of just saying tiger, I'm going to give it an actual species name this time. So we're going to update the species, and it's going to change that value. So now tiger.species equals Panthera tigris, or tigris. And that's basically how we deal with objects. We could create another object. We could create like dog, and we could say const dog equals new animal, and we could have spot and dog, and its name would be dog, or I'm sorry, its name would be spot, and its species would be dog. And it'd be that simple. So basically we created a blueprint for making any type of dog that we want, or I'm sorry, any type of animal that we want. And that's what objects are. They're just using that blueprint to build whatever that thing we have made a blueprint for is.